Hello and welcome, children, to another science journal with me. Today we'll be discussing my alleged homeworld, Earth. The Earth is the third rock from the Sun and the only one in our solar system supporting complex life, as far as we know. It also happens to be the one we named Terran planets after, since Terra is actually Latin for Earth. So any Terran planet, like Mercury or Venus, is just one that's rocky on the surface, like Earth. We're also the innermost planet with a moon, but we'll talk more about that later. On average, we stay just under 150 million kilometers from the Sun with a maximum temperature of about 58 degrees Celsius and a minimum of about negative 88 degrees Celsius. Luckily, this allows about 75% of the Earth's surface to be covered in liquid water, since, we really wouldn't exist without that. But let's get into the rest of Earth's structures. We start in the center with a molten core of mostly iron and nickel, which is just over 3,500 kilometers thick. Surrounding this core is a molten mantle about 2,900 kilometers thick, which the tectonic plates float around on. This brings us to the crust, which is the outside bit that we walk around on all the time, and it ranges from about 3 kilometers thick to about 19 kilometers thick. Around all of this rock is a thick envelope of gases we refer to as our atmosphere. Far more existent than Mercury's and not nearly as toxic as Venus's. This atmosphere is as critical to our survival as our oceans. But, like onions, our atmosphere has layers. The troposphere extends about 14.5 kilometers above the Earth's surface and is where almost all of our weather takes place. On top of that is the stratosphere, which is about 50 kilometers thick. Then the mesosphere, with a depth of about 85 kilometers, followed by the thermosphere, about 600 kilometers thick. All of this includes the ionosphere, which ranges from about 48 kilometers to 965 kilometers above the Earth's surface and makes radio communication a possibility. On top of all of this is the exosphere, the outermost layer of our atmosphere, which extends up to 10,000 kilometers above the Earth's surface and contains most of our man-made satellites, including the International Space Station. All of this atmosphere is then encased within a magnetosphere. This is the magnetic field created around our planet by all of the molten metal sloshing around in the core. Without it, our atmosphere would be whisked away, more on that when we get to Mars, and our satellites wouldn't be able to function at all. Now, let's discuss the moon, because that gets real interesting. Not only is the leading theory that the moon is actually made of Earth, but it's also slowly inching away from us. Back in the early solar system, when all those massive collisions were going on, like the one that blew off half of Mercury or the one that made Venus start rotating backward, it's believed that a massive collision took place here on Earth. Rather than affecting our planet's movement, though, it blew off just enough material to create the moon. What's even more fascinating, though, is that the moon used to be much closer. The moon was likely about 24,000 kilometers away when it first formed, but now sits a little over 380,000 kilometers away. How could this happen, you may ask? The answer, essentially, is tidal effects. We all know that the moon pulls on the oceans, but it also pulls on the rock that makes up the Earth. In turn, the Earth pulls on the rock that makes up the moon. Both bodies then become oblate spheroids, or egg-shaped. Because gravity takes time, however, the bulges on each body don't quite line up. As a result, the Earth is slowed down by a process known as tidal braking. At the same time, the moon is sped up in its orbit. This also requires the moon's orbital distance to increase in order to satisfy the laws around the conservation of energy and angular momentum. This radius increases at about 4 centimeters per year, or just under 2 inches per year. Eventually, the moon will reach what's known as its hill radius, and the Earth's gravity won't be able to hold it anymore. We will then lose our moon to the sun. Not for a very, very long time though, so don't worry about it too much. That's it for today, guys. I hope that you enjoyed this video, and I hope that you learned something from this video. If you did, maybe give it a thumbs up and hit that subscribe button to help support my channel. You can find my written script with references in the description box below, along with my previous solar system videos and links to everything that popped up in the cards throughout the video. Let me know in the comments if you have any questions, and until next time, stay curious.